ഹലോ. ആടാ. ഒരു 6 മണിക്കാവും കിട്ടാനായിട്ട്. അവിടെ പോയി വാങ്ങിക്കണം. ഇവിടെ തുരൈപ്പാക്കം, അവിടെ പോയി വാങ്ങിക്കണം. നീ നിന്റെ അങ്ങോട്ട് എങ്ങനെ വരുന്നത്? കോയമ്പേടുന്ന് ബസ്സാ? കോയമ്പേടുന്ന് ശ്രീപെരുമ്പത്തൂറാ? ശ്രീപെരുമ്പത്തൂർ. എന്നിട്ട് അവിടെ നിന്റെ ഹോട്ടൽ എവിടാ? അവിടെ അടുത്ത ഉള്ളോ? ബൈപ്പാസ് എന്ന് പറയണോ മറിയ ബസ്സില്? ആണോ? ശരി ശരി. ഞാൻ നോക്കട്ടെ. അല്ല, അതൊക്കെ വാങ്ങിച്ചോണ്ട് വരാം. ആദ്യം ഞാൻ നോക്കട്ടെ എങ്ങനെയാണ്. നീ ഇവിടെ തുരൈപ്പാക്കം വരെ പോകണം. തുരൈപ്പാക്കം ഇവിടുന്ന് കുറെ ദൂരമുണ്ട്, 10-15 കിലോമീറ്റർ ഉണ്ട്. അത് പോയി വാങ്ങിച്ചിട്ട് പറഞ്ഞു. വാങ്ങിച്ചിട്ട് വന്നിട്ട് പിന്നെ നിന്റെ അങ്ങോട്ട് വരണം. ഞാൻ നോക്കട്ടെ. അവന്മാരവിടെ എനിക്ക് തോന്നുന്നു അവന്മാര് ഏതാണ്ട് ജോലിക്കൊക്കെ പോകുന്നവന്മാരൊക്കെ. അപ്പൊ അവന്മാര് ആ സമയമൊക്കെ ആകുമ്പോഴേ വരത്തുള്ളായിരിക്കും. ഞാൻ ഞാൻ എടുത്തിട്ട് അങ്ങോട്ട് വരാം. ശരി. Good afternoon, everyone. We will start the session. So I'm myself Nivin. I'm from pantechelearning. So I work in embedded department in pantechelearning. So today's session, I'll be taking the session today. So in today's session, session is about Industry 4.0, and we can include, there are like, we can include in industry, when we say Industry 4.0, we can include so many different things. So Internet of Things, one of them. So today we'll be talking about Internet of Things from a embedded point of view. So initially in general, we'll talk about in general Internet, history of Internet, and the reason why Internet of Things emerged. So we'll talk about all that initially, and then we'll go into Internet of Things from a perspective of embedded systems. So Internet of Things you can implement in using in different ways. So it doesn't have to be a hardware-based system. It could be fully software-based. So many companies, so many users the software-based Internet of Things for different type of purposes. Different type of AI, systems, AI programs. They all use this type of Internet of Things. So they don't need any kind of. So the basic idea to say what is an Internet of Things is to uh, we can say that it is a system which doesn't need any kind of human help, human interference to you know run itself. So it can access the internet. So the accessing the internet is accessing the internet and collecting data, transferring data. That will make any system a automated system, an Internet of Things system. So that means any system that is built for any purpose that is connected to internet can be part of Internet of Things. So we'll talk about in broadly we'll talk about the Internet of Things. So before that we'll start with the history of Internet of Things. So before that, Internet of this just the same as I just explained. Internet of Things in basic sense it means any anything can be an object, any object. So the object uh, can be just a software, or it can be hardware system which is doing some kind of function. It is either it is repetitive, or it can adapt based on, it could be an AI system, can adapt based on different situations, or it could be a chat board system, could be any type of system, or it could be a hardware system with sensors, or it could be a robotic system, or it could be an autonomous driving system like autonomous car or autonomous truck. So so this thing is connected to a network, and it uses the network for some purpose. So if you take different type of, so these days if you take uh, autonomous car system, one of the best example is Tesla cars. So these Tesla cars are actually, they are not just a hardware, like cars in the in like 2 decades ago, cars means just a mechanical system, mechanical machine, automobile, system that is just consists of a IC engine, any kind of different kind of IC engine, whether it is a diesel, petrol, or whatever it is, and it has other peripheral things to make it work. So that is basically what a car or any kind of automobile used to be. So these days it is different now. Even if you take a base model car, it will have so many different type of computing systems inbuilt in it. So for automation, for safety, for different purposes. So Tesla is one of the best examples. It is one of the most advanced type of cars. It's an electric vehicle, and it has its own intelligence, and it has a software part, and that means the software part is always connected to the network, to the main server, and it will check for updates like your Android phone or your Apple phone or any kind of phone you have, or a system, Windows system you have. If you given consent for automatic updates, automatically it will update the OS whenever there is an update, like whether it is 6 months or 1 year or whatever it is. Whenever there is an update, it will update the OS automatically. The same thing happens with the Teslas too. They can connect to the internet, and they can automatically, without asking consent, they can automatically download the new software updates. And the software updates actually can even, it's not just a system like a different type of security or other type of systems. It can actually improve the performance of the car in some cases. So if you learn about these type of you know if you learn about Tesla cars, you can, if you watch different type of videos, you can see that they'll explain that it can actually increase the performance. It can actually increase the speed of the car, increase the performance of the car, software update. So we are at that level right now. So that is the, like, the end point right now. We will discuss from beginning how it emerged. So we will start with the internet itself, how internet came to existence. So this is a chart which shows internet revolution. So this here shows the different significant eras of internet. So internet can be divided into so right now internet can be divided into 5 different eras. So in future it will be, so industry 4.0 is the next era, is the next level that we will be moving into the internet. So the beginning, it was 69. So the internet was already in existence, but it wasn't called internet, or it wasn't exactly called internet, and it wasn't exactly like the internet that we use right now, or the internet of the later stages. It was in 69 there was a interconnected network called ARPANET. So the ARPANET was the predecessor of internet. It was a network that interconnected. So already computing system have improved so much in 60s, in early 60s. Already it improved so much, and it was used in research purposes. Computers were used in mainframes and other type of systems. Computing systems were used in uh, research research labs. So ARPANET is a network that was used to interconnect all these different networks. So which networks, like, we know about education systems in the US, in America. We know there are like these prestigious institute called Ivy League schools. So these are like universities like Stanford, Harvard, or MIT, Caltech. These are like high level universities, and they have research labs. And these research labs are funded by the Defense Department. So the Department, any in any country, the biggest investor of any kind of scientific research is the government itself. So the government will fund, like, for example, even if you take an individual PhD candidate, if your research subject is actually useful enough, then you will get grants, different type of grants from government for you to continue the research. So that is on an individual level, but there will be like so many bigger projects that governments run research project. So that is not that is a for a PhD candidate. So the research can be of any level, like a multiple person team can be researching on one thing, purely scientific thing, that is a futuristic thing. Like for example, if you take these days research is going on in quantum computing, so that is a one era, so in next era that will be the classical electronic systems will be replaced by quantum computers, and the classical networks will be replaced by quantum networks in the in coming in coming years, okay, coming decades. So at that time there was like in 60s there was like they were using this, so these Ivy League schools, they had the defense department, US defense department had different type of research projects going on in all these different institutes. So that the it could be like about weapon research, or it could be other type of scientific research, or could be like different type of medical based research. So the defense department is actually interested in all these different variety of research areas. It is not just restricted to one single thing like weapon development. It's more than that, for different purposes. So that all these institutes had different defense research projects. So they had to interlink. So the multiple institute could be researching on the same thing, or one institute could be researching on one part of one thing, and other part could be researched in another place. So they had to interconnect all these institutes, all these research labs to make the process more efficient. So they if they are able to communicate in real time, if they are able to interconnect, and they're able to share their results in real time, then the research will become more faster and more efficient. How? Because we know that if there is 10 people working on one thing, and then 10 people working on another same thing or similar thing in another institute. The institute could be like 1,000 kilometers or 5,000 kilometers away from the first one. So the correspondence will be very hard if it is without any kind. If it is not in real time, then the correspondence will take so much time. If it is through some kind of a telegraph or whatever methods they used to have, they use any of those methods, or like radio communication, whatever they use, it won't be. Huh? അതൊന്നും എനിക്ക് தெரியாது. இது எங்கிட்ட இதை தான் சொல்ல, இன்டர்நெட் ஆஃப் திங்ஸ் தான் ഞാൻ எடுக்கும், வேற எனக்கு தான் தெரியாது. அதுதான் இண்டஸ்ட்ரியல் ஐஓடி ஒன்று எனக்கு தெரியாது. Okay, so we'll continue. So that era is called Internet of Boffins. That means all these researchers, all these different research institutes were interconnected to communicate in real time, so they can share their results in real time, and share their results in real time. So to make the whole the make the whole effort more resourceful and efficient. So that at that time it was just exclusively it was used by uh, it was exclusively used by defense department, and defense department only the people who are authorized by the defense department can access the internet, can access that ARPANET. So ARPA is the research wing of defense department, US defense department. So that's why it was called ARPANET, for interconnecting all these defense research labs in different multiple institutes. So that was the original idea of this original idea of internet. So it was like I said, it was exclusive. Only certain people, authorized people, can access it. It was not public. So then, so this continued till 1995. 1995. Then they began to think about like then even in the early 90s they started giving other people other academics. So it wasn't useful for most of the public because it wasn't they couldn't use it in any kind of real life application. So but they given access, so they started giving access to different type of other academics, and then so then uh, different type of, they can pay a little amount and they can get a registration, and they can do the registration, and they can access the network for different type of purposes. And then after 95 it became the internet was made public. So it was made public. It was they had the idea that it is useful to interconnect all the different small networks. So internet means, like in the original form of internet, that was ARPANET, or in the current form right now what we are using internet, it is just a collection of different small networks. So if you take an area or a campus or whatever, they'll be having a number of systems, and it will be interconnected. These are systems will be interconnected, and it will be connected to a switch, and that switch will be connected to another switch. So that is how the internet is working. It is a collection of multiple small network. So anyone can create this type of networks and connect to the internet. Uh, so then in 95 this was made, so any network, any small network was able to connect to internet, this bigger system. So it was made public in 95, but still in 95 the internet wasn't that useful for no most people, because it didn't have any kind of real life applications at that time, and also it was very slow. It wasn't useful for most people. So only these people who are actually interested in like science or technology, only these people were accessing internet. So that's why it's called Internet of Geeks. Internet of Geeks, at that time it had like limited capabilities, like you can use chat rooms and emails and different types of things. So these were only used by, or only used by a small community in like developed countries. So it wasn't a big thing all around the world at that time. So that's why it's called Internet of Geeks. Only like a certain amount of people, or certain class of people were using the internet. And also it was because the systems were very costly. To connect to internet, it is very costly. You have to pay so much money monthly, and you need to have a computer that is not affordable for most people at that time. So like in 95 PCs already exist in 95, in 80s, late 80s and 95 PCs already exist, but still these PCs were very expensive for most people. So they weren't able to accessing internet, and even if they were able to access, then they doesn't have that much applications for real-time application for them to make it useful. And then after that comes the internet of masses. So we all know about the IT boom, and that happened all around the world. So the in India, Bangalore, how Bangalore became a industrial center, like it because of IT. So they so like a company like companies like Wipro that was established at that time. So that is one of the biggest IT companies in the world right now. So like in early 95s itself, at the time era of Internet of Geek itself, there were like big companies. They weren't big that at that time. So these companies are like Amazon is one example. Amazon already was established in 96, in 1996. It was initially it was just a book delivery system. You can order online. Online you can order books without going to a bookstore. You can use internet to order books. So that was the initial idea of Amazon, and then they expanded to different type of uh, retail retail systems. So the 2000s made internet more. The early 2000s made internet more popular, because internet became more connected, and all over the world internet became more available, and so because of that, different type of businesses started, like Amazon. Different type of businesses started, or specifically based on internet, or solely based on internet, solely using by internet. So that means people can use internet for different like the for this Amazon example, they don't have to go to a bookstore to order a book. So that is very convenient for most people. They don't have to. They while they're working, they don't need to go to a bookstore and browse for different. They can go. They can use their PC and they can check their PC while they're working or while they're at the home. They can browse whatever book they need and they can order that. Then it will be they'll receive that at their doorstep. So that is very convenient way of purchasing books. So that same like that, similar to that, there are like so many different type of applications, so many different type of things was added to internet and added to internet. So that made internet more popular. So that is the era of internet of masses. So internet of masses is popular because people even like people who are not even like interested in technology, or people who are working in different type of areas industry were able to were using internet in a very useful way. So this made it more popular. So that still at that time, internet wasn't exactly that popular because still people needed to buy a computer to access internet. They need to buy a system. They need to buy a personal computer, PC, to buy a laptop or a desktop to access internet. So at that time it was costly compared to right now. At that time it was costly, and even if you have a system, the computers weren't that costly, but still uh, but even if you have a computer, still getting an internet connection, it was easy to get an internet connection, but to get a high speed internet connection, it wasn't easy. It wasn't about the ease of getting it. It was about the how much expensive it is. Like it will be very expensive if you get a dial-up system, dial-up internet connection. It is not that expensive, but the thing is that it is very slow. It can only like give like kb per second, very kb per second internet speed. So that means you cannot do like downloading, you cannot do most things. So you can browse maybe websites, you can do that type of things. Even that will take so much time. But so that dial-up connections or these type of connections were only useful for only affordable for most people. So it wasn't exactly popular in that way. But that's why there was it was era of internet cafes. So internet cafes were very popular at that time. So if you live through that time, you can remember that time. You can go to a internet. We would go to an internet cafe for different type of purposes, like for using social media, or for applying for different type of jobs, or any type of purpose. We'll go to so to watch YouTube videos, whatever it is, we'll go to internet cafes, because in internet cafes means they will have multiple systems, like 10 or 20 systems, and they'll have high speed internet because they can afford that, because they are a business. So they can charge people for hourly, on hourly basis they can charge people. So that means they can get high speed internet by giving a particular amount. You don't need to you don't need to have a monthly subscription, very high costly monthly very expensive monthly subscription. You can just like pay 1 hour or 2 hour amount, and you can use the internet, very high speed, high speed internet. That was time of internet cafes. And then after 2007, the late 2010s and the early 2010s and 2007, after 2007, the mobile internet era, that was the start of mobile internet era. So before that, mobile phones were like there were camera mobile phones. Even in 2000, like 2005, 2007, 2008, there were camera mobile phones, color mobile phones. Nokia, different type of Nokia, BlackBerry, different type of mobile phones. You can use them for different purposes, not just for calling. Before that, the mobile phones were just solely for calling. You can call different people and you can text message. That's all. Then there were like small games and different type of applications were there. You can store your contacts, and even before that, if there was nothing was possible like that. You can only like call. That's all you can do using mobile phones. And they were like big phones. And then after that, small Nokia black and white small phones were there, and like 1100 phones, small phones were there. And these phones can be used for calling, text messaging, and you can play small games. Um, and you can say contacts in that. They were using them, and after that, color mobile phones. Even using those mobile phones, you won't be able to access internet. There is no internet access. You can just the SIM card scan, using the SIM card you can call or text message, and then you can take videos and photos, but you cannot use upload them to internet or anything. They were not able to connect to internet. And then afterwards came the era of mobile internet. So that means using the SIM cards we are able to, using the mobile network, the same mobile network, we are able to access the internet. So the mobile network providers becomes ISPs, and uh, they provide internet services for the people who are using that network. So that like 1G, 2G, that type of system, GPRS systems. So these were implemented in 2007. So the mobile means it is more affordable. Class எடுத்துட்டு கொஞ்சம் வெளியே அங்கே உட்காருங்க. So like, so mobile means it is compared to a desktop, a PC. Mobile is much more affordable. Mobile phone is much more affordable. So it became more popular. The internet became more popular. More people were able to access internet because they can afford a phone, a mobile phone. They cannot maybe afford a PC and then an internet connection that is very expensive. PC itself 20,000, more than 20,000 it will cost, and then you have to get a internet connection. But with a mobile phone, you can buy a mobile phone for 10,000 or more than less than 10,000 or more, little more than 10,000, and you can at the same time you can get a SIM card, and that SIM card you can pay for internet on that SIM card, and you can use it for different type of purposes. Still, it wasn't even in 2000s. You cannot use it for that much, like we used right now. Because phones weren't that advanced at that time. They were like Symbian phones, Symbian OS phones, or BlackBerry phones. These are not able to use like internet the same way we use right now through using our smartphones. Then that means more people, more. So throughout this different eras, you can see here the one factor is that number of devices connected, how many devices are connected here. So like here the number of devices connected is very limited. It's only like certain research labs, machines in research labs, and then here it increased, but not that much, not became drastically increased from this point to this point, but still it is not that much. Then internet of masses, it increased so much because of internet of the IT boom and the internet cafes and all that. It increased so much. More people were able to use the internet, and then 2007 from that the number of devices again increased because of mobile internet. So more devices were connected to internet, and then beyond 2012 it is era of internet of things. Beyond 2012 the automation became more popular means it became more liberal, became more useful for common people, for everyone. So before that, automation means it existed in research labs and places. So after that, automation became people were able to use automation for different purposes, with like machine learning existence, or like coming of machine learning, AI, and all those things. So there were more automated systems, and the people were able to use it. Became more liberalized, so that means the number of automated systems increased very drastically. It increased. So that is the beginning of era of Internet of Things. So automation is a very important point in Internet of Things, because Internet of Things means it is machines that are able to access the internet and do some process on its own without any human help. So that means it is a fully automated system. So that is the idea of that's how the Internet of Things came to existence here. So that is in 2012. So this is what we are going to see from This point we'll be discussing about 2012 beyond and the era of Internet of Things. So in this in all these cases, the common factor here is the number of devices connected. That is one factor. So that is one factor that gave rise to the idea of Internet of Things, the number of devices connected. So I'll show you another chart in another slide, and I'll explain with a number. I'll explain that, so you'll get that, get the idea. So like why internet, why we use internet to interconnect all these things, anytime, anywhere, any person, any business, any device, any network. So any network can be connected using any devices. So any type of business can use the internet. It is not just for a science or scientific or educational purpose. It can be used for by any type of business. Could be a retail vendor, or it could be uh, medical purpose, could be research or education or transportation, logistics, could be anything. So any business can use internet for their purposes, and any person, anywhere, anytime. So this anywhere is not still not fully established there, because there are so many places in the world still they don't have internet connectivity. So because of various reasons. Uh, but in the future, maybe that will be rectified, and we can say anywhere. So like anywhere, and also that another problem with anywhere is that it is the current system, internet system, is fully based on wired systems. So we need to have the international internet cables that's what interconnect these continents, different continents, interconnected through these international internet cables. So there's a whole industry that is working on dedicated fully for that, for maintaining these cables and checking these things. So it is fully interconnected. So with like if we are able to make it totally wireless, and in future with some technology, then it will become more accessible. Then internet, some features of internet, no one owns it. It has no formal management. It does a it has a it as it was originally developed by Department of Defense, it lacks a lack of centralization made it less vulnerable to wartime terrorist attacks. So any centralized system can be uh, can be attacked by very easily. You just have to go to one place, and if you attack that one place, then it will be the whole system will go down. So but internet is not like that. It is a decentralized system. Then to access internet, existing network need to pay a small registration when I agree to certain standards, TCP/IP. So these standards are very important, because the different type of networks and different type of machines should be able to communicate, like send and receive data. So then the history of Internet of Things, and up to now we were talking about history of internet. So now, when we go into history of Internet of Things, the first person who coined the term Internet of Things is Kevin Ashton in 1999. And what is Internet of Things? Internet of Things is a network of physical objects, vehicles, buildings, and other items embedded with electronics, software, sensors, and network connectivity that enables these objects to collect and exchange data. So this is a uh, so this is the same thing that I was talking about in the beginning. Like any object can be anything. It can be a vehicle, a building, or an appliance at your home, or your home itself can be anything. So then it is embedded. So the if you take most of the objects, like vehicle is a purely, if you take vehicle in its pure sense, it is a mechanical machine. It is a automobile. It is mechanical machine. So it cannot connect by itself. It cannot connect to internet. So it should be embedded with some electronics hardware, and then some software, and it should be connected to a network. Uh, and depending on the application, should maybe have some sensors or actuators, and it should be connected to a certainly need to be connected to a network that enables these objects to collect and exchange data. So basically, whatever we do using internet, it is collection and exchange of data. we whatever we using social media, or we are watching a video on YouTube, or we are applying for some job online. We're just exchanging, we are reading, receiving data, and we are sending data. So that is what basically happening there. So that's the same thing here. Basically, any kind of whatever we do in internet, that is solely for this purpose. So this is like a brief basic definition of Internet of Things from an embedded purpose perspective, from an embedded system perspective. So in a single sentence, anywhere, so different type of gadgets and different things, all world in one hand. And one important idea in like Internet of Things is machine-to-machine communication. So the machine-to-machine communication means like automated machines. So like so automation is very important point in Internet of Things. So machine-to-machine communication is possible because machines are able to machines are fully automated, and without any human help they can communicate each other, and they can do they can execute some task using their own like predefined, or they could be intelligent machine like an AI machine. And then anyway, like electricity, one example is you can use like internet itself. Like when we discuss about internet, I told you that internet can be used by any business, like any for any purpose. It can be used for its applications are limitless. It can we can add a new applications for internet. Like every day we can invent something new for internet, some new applications for internet. So its applications are limitless. Same as that, Internet of Things also is limitless. It can be used in any kind of technology or any kind of area. Uh, so one example here is on your campus. So in on a campus, or the campus could be like in this example, it is a school campus. In this example, it is a school campus, but can be used in a university campus or a industrial campus or IT park. Could be you can use it in any of these examples. In all these examples, they have the similar kind of they can be used in similar kind of applications. So in this is an example Internet of Things in school, in a school campus, how we can use Internet of Things. So then you can start from here, like personalized learning. So there are, like you can see here itself, you can find so many different applications, but these are not all the different applications that you can use. Like I said, it is limitless. So in a school campus, in a single scenario, like in a school campus, you can use the Internet of Things in so many different multiple cases applications. So personalized learning with adaptive e-textbooks and digital classroom and whiteboards and displays. iBeacons. So iBeacons can be used for tracking purpose. So for tracking for different for tracking people, you can use iBeacons or in international collaboration and social exchange. So like you can use it for international collaboration. Like there are like so many universities all around the world have exchange programs. So exchange programs means you can from one university, one place, one for example, if you take like India, will have exchange students in universities. So these exchange students, they will come from different other countries, and they'll study here because of some based on some program. So this is for like some students from here will go to their place, and then so these are like exchange programs. And this type of exchange programs are exist already, but that can be made more popular by using internet. The person doesn't have to be there physically. They don't have to be there. They can go to their own campus, and they can take classes from another university. That is a useful case thing in Internet of Things. And online testing, sensor on trash replace receptacles. So in cleaning and trash collection section, you can use the interconnect like different trash bins dumpsters into a single network, and the people, the maintenance people, can be alerted every day on a regular basis how which one is empty, which one is full, and which one needs to be emptied. and robot cleaning systems. So like we can have multiple automated robots that can clean places. So these robots can interconnect and they can coordinate to clean different parts of the school campus. And augmented and virtual reality based learning systems, and robotic STEM and remote presence labs, uh, student devices, e-textbooks, notebooks, tablets, smartphones, file and storage, local and cloud-based, demographics, academics, behavior in interest, LMS, CMS, is educational programs, applications, and video files, lectures, and recorded lab experiments. So then network application analytics and monitoring devices, network behavior, surveillance security systems, different type of surveillance and security systems, and school parking systems, like automated parking systems, and sensors track buses, verify student passengers. So like this could be useful for like lower standard students, lower class students, like students up to like 10 years or 8 years old, 9 years or 10 years old. They can, parents can track their students. They'll get notified when the student enters the bus. So students will be provided with a tag, and the student, either it will be a NFC based tag. NFC means you don't need to tap anything. You can, while you're entering itself, like in case of NFC is used in toll systems, in fast tag toll systems, where the vehicle doesn't have to pay the amount. They don't have to stop and pay the amount while the vehicle is nearby, like within like 10 meters or 5 meters of the toll gate. Automatically the payment will be made, and automatically the toll gate will be open and the vehicle can pass. They don't even have to stop. So that is like implemented in like countries like cities like Dubai, that is implemented. Countries like UAE, that is already implemented, and even in India it is implemented in places. So this, that uses NFC, near field communication. So you can use the same kind of technology with the students. Students can have an NFC tag, and the reader can be put in the bus. And while they're entering, they don't have to swipe because they are children. So maybe they will swipe, they won't swipe. So to make sure that they are noted, you can make it an NFC system. While they're entering the bus, once they're inside the bus, it will be registered as the person is inside. And if they leave the bus, then again the person left the bus. So the parents can get a notification every day. They can get a notification morning time and afternoon time, evening time. They will get a notification whether the students their child is in the bus or left the bus. So it will be more secure in case of lower standard students, small children. So then monitoring and display of air quality throughout the school. So air quality of school can be monitored and displayed through different type of display systems. And Internet of Things based HVAC, and make a space for 3D printers and laser trimmers, wearable for athletics and attendance tracking. So attendance doesn't have, you don't need to, the same NFC system can be used for attendance system. Once the student enters the class, automatically attendance will be noted. So the person doesn't have to go and take attendance manually. Automatically the attendance will be taken. Supplies and inventory tracking by sensors with auto recorders. So these are like some of the examples, in one single scenario, that is a school campus. So then still we can expand to so many different cases, so many different applications, and we can have like limitless amount of scenarios, say, similar like this. And connected devices. So this is the main factor in emergence of Internet of Things, the number of devices connected. So this chart here shows the number of devices connected throughout different uh, years. So here it shows world population and number of connected devices. So connected devices per person. Then there is a ratio here, that is the uh, connected devices divided by number of people. So here you can see the number of devices is 500 million. In 2003, number of devices is 500 million, and the world population is 6.3 billion. So the ratio is 0.08. So that means even uh, for uh, less than only like for 0.08 is the ratio. So that means each person doesn't have a device connected to internet. So the number of devices is very low. It's very high. 500 million is a very high number, but still compared to the population of world population, it is very low, 500 million at that time. Then again, you can see like in 7 years, more connected devices than people. It jumped into, so here the number of devices is much less than the number of people. It's only zero point 0.5 billion, and the world population is 6.3 billion. So it is very much less than the world population. And here, the in just 7 years, the number of devices connected became almost twice as the world population. The world population becomes 6.8 billion, and the number of devices, connected devices, becomes 12.5 billion. So 1.84 is the ratio. So that means it is almost twice as the world population. So for every single person, there is almost two devices connected to internet in 2010 itself. Then in 2015, after just 5 years, you can see the ratio becomes 3.47. So the number of people is 7.2 billion, and you can see the world population increase. Increase of world population is small, but the increase of number of devices is very high. 0.5 billion to 12.5 billion, then 12.5 billion to 25 billion, twice as in 2000, in just 5 years, in half a decade, it increased to 25 billions. And then again in 2000, in 2020, it became, the world population is increased just 0.4 billion, 400 million, but the number of devices doubled. Number of devices connected to internet doubled. So here you can see 6.5, ratio is 6.5. So 6.5 devices is connected. For each person, 6.5 devices is connected. So you can see, this is from this chart representation, you can see the number of devices connected and the world population. It is not even if every person is using a device or two devices, still it is not possible for all the people to use all the devices connected to internet. So a person controlling the device is not possible here in this case. And still and we know, like even in 2020, there are like so many all the 7.6 billion people in the world are not able to access internet. Still there are like so many places, and even in 2022 there are like so many places where the internet connectivity is not a reality, still exists so many places. And so the ratio here, it signifies one thing, that all the people cannot use all these devices. Even a person uses 3 devices, still it is not realistic. So that means so many of these devices are automated devices. They can do things on their own without any human. So that is the era of Internet of Things. The devices, the machines are able to use internet without any human help. Then hype cycle of IoT and different type of technologies. Internet of Things comes here. Peak of inflated expenses and expectations, and different NFC mobile. So you can see different type of technologies here, and Internet of Things comes here. So this is a graph of expectations and plateau of productivity, experiences and time. Then layers of Internet of Things. So layers of Internet of Things means you can divide the Internet of Things into different layers. Like any Internet of Things system can be divided into this type of different type of layers. So initially, like whatever we are making, like any technology, whatever it is, the end user is always human. Is a person. Is multiple people. Whatever technology that we make, most of the research that is going on in the world right now, it is for to make human life more convenient, more easy, uh, more efficient. So that is the idea of all the research that is going on. It is make us medically or whatever purpose it is, education, whatever it is for the advancement of human race. And in some cases, in some exceptions are there, like for example, like environmental cases, for environmental purposes. Like it is not in environmental case, for in environmental research cases, it is not just for humans, it is all for the whole world actually. So because the whole, like animals or the ecosystems, so to sustain all this, we need so much research, and we need to replace so much of the current existing practices with the new practices to um, make you know make like these and make environmental problems much more less drastic. So if we go in the same pace, there are so many different disasters can happen. So that is one scenario in which it is not just solely for humans. It is all for humans, but it is not just exclusively for humans. But most of the other technologies, other research that is going on is for humans. So any other technology, Internet of Things also at the end user is always a person or a process. Process is in turn is used by the person. So that it means it is the highest level of the different layers. So layer 7, transformational decision making based on thing and app and data. Different type of applications, internet applications, and very useful used by humans. Then applications, custom built using thing data. Application could be a software application or hardware application. So it is useful for humans. They can use it for in whether it is hardware based or software based. So applications. So second layer is comes application. Second layer comes application. So this business comes under business values. Then big data comes under in big data. Data analysis and data ingestion comes in big data. So data analysis means machine learning, AI, all these comes under big data. So AI means it is generally data ingestion, data analysis, all this comes under AI, artificial intelligence. Data analysis means machine learning, data science, all these comes under data mining, reporting, all these comes under data analysis. An example of this can be like any kind of sensor-based system. For example, like in industrial area, there are like so many different chemical plants are there, and we using different type of sensors, air sensors, we can measure the content of the different elements consisting of the air that is that is being breathed by the people that are living there or working there in that industrial area. This is the case in so many states in India itself. Um, like you take Gujarat or Maharashtra, these type of states, they have highly industrialized states, and they have like in the cities that are solely dedicated to this one purpose for industries. So these in these places, people also live there, so they have to. So we can use this type of machine learning systems. First, it should be an embedded system. With an embedded system, you can measure the different contents of air, and then that data can be sent to a cloud system. So that cloud system can then in that cloud system itself, like you can use like systems like AWS or MathWorks, ThinkSpeak, these type of systems, these type of cloud services. These cloud services you can use different type of Google's cloud services. In this cloud services, you can write machine learning programs, and you can collect the data, and the data will be automatically fed to the machine learning program, and predictions can be made for different type of purposes, like whether if a person breathe the air for like a particular time period, what type of complications can happen, health complications can happen in that person. So that type of things can be implemented using this data analysis with the help of Internet of Things. Then data ingestion. So we know about data ingestion, like big data and harvesting and storage of things, like personalized advertisement. All these comes under this type of things. So like by collecting our browsing data and different type of things, data these systems can predict. These systems can predict predict what type of products that we need, and based on that they can recommend different products. Personalized art systems, and then data ingestion, Then global infrastructure, like different type of cloud infrastructure, like I said, ThinkSpeak or AWS, Google, different type of Google Cloud. These are like some of examples of clouds, like leading cloud services available right now. And connectivity and edge computing, communication protocols, network, M2, mission-to-mission communication, Wi-Fi, telecom, hardware kits, all this comes under connectivity and edge computing. Then things means the end layer is the things itself, like whatever thing that we use, like devices, sensors, controllers, all these comes under things. Then different type of scenarios, how to communicate. So this is just a brief explanation of definition of sensors. Sensor is a device that measures a physical quantity and converts it into a signal, which can be read by an observer or by an instrument. So yes, sensor, like any kind of sensor. If you study about sensor, if you study electronics, if you are studying about sensors and actuators, and if you study sensors, you know that every sensor has a dedicated mechanism that it uses to convert a physical parameter into an electrical signal, so that it can be used for. Then that electrical signal, it could be a analog signal, then that analog signal can be used, converted to a digital signal using an ADC, and then it can be used by a computing system for different purposes. Either it could be for storing the data in an Excel sheet and using that Excel sheet in future for data analysis. So the like an example of this can be a temperature sensor. Like one of the basic type of temperature sensor is called LM35 sensor. So it uses the the mechanism of a semiconductor. Semiconductors like silicon, semiconductor material like silicon are susceptible to external temperatures. Different factors like external temperature. So this temperature susceptible device can be used for measuring temperature, because based on the, we can make the normal silicon based electronic systems are made to compensate for this type of external effects, so they won't affect the working of the system. But the but in case of LM35, this very thing is used for measuring the temperature. So it is more susceptible, more than any other type of semiconductor devices. It is, this LM35 is more susceptible to temperature. That means it can, based on the temperature, external temperature, its conductivity will change. So that means the current flow through it will change. So the voltage will change, voltage will vary. So based on the voltage variation, you can measure the temperature. So that is one scenario. There is only one single mechanism and one single example of a sensor. So that similar like that, all the sensors use some kind of mechanism to measure a physical quantity or convert a physical quantity into a electrical signal. Then these are like different type of examples of different type of sensors. This is a water. This is not a level sensor. This is a flow sensor. It is for measuring the flow rate. An electricity sensor, like a current sensor. This is a analog current sensor, and this is another type of current sensor. Then LDR sensor for light measuring, and analog sound sensor for measuring sound. And there are two types of sensors: digital sensors and analog sensors. So in this case, this one is a digital sensor. A flow measuring sensor is a digital sensor, because it uses ticks. It has a rotor inside. So while the water is flowing, water or any liquid is flowing, the rotor will rotate. So the number of rotations can be count using ticks, number of ticks. So each rotation means one tick. So that it uses a one. So one tick means one high. So it's a digital sensor. It uses interrupt to measure the current, the flow of any liquid. And all these other sensors are analog sensors. Proportional or analog sensor, discrete or digital sensors. Then discrete sensors can be classified into two devices: active low or active high. 0 to 1 means active high, 1 to 0 means active low. Then different type of controllers or single board SBC, single board computers. So these are two examples. These are not used in industrial cases. Like this is Arduino Uno. Arduino Uno is not mostly used in industrial cases. These are like Arduino Uno is mostly used for prototyping, research purposes, and prototyping and educational purposes. And Raspberry Pi is also similar type of board. It doesn't have that kind of computing capabilities that an industrial system needs. So it is mostly used for educational and research purposes, prototyping and research purposes. This is a single board computer. This is a mini computer, and this is the controller board. So we can use ARM controller boards like ARM Cortex boards, like LPC boards or STM boards. So these are like different type of or MSP 340 MSP boards. So these are like different kind of industrial boards that are used. So this ARM Arduino Uno is actually for prototyping. It is easy to program this, so we can make a system very easily. So there is it used for prototyping. And cloud, different type of cloud systems, big data, and so we have seen big data, or that in characteristics of big data, data quantity, data speed, data types, requirements. So it's a chart representation of requirement and searching and usage in different type of industries for Internet of Things. Applications of IoT, safety and security, like driver drowsiness detection, driver recognition, like for security and safety, driver drowsiness detection and obstacle detection, stop sign, like road sign recognition. These type of systems are part of Internet of Things system, broad Internet of Things system. Connected cars, traffic management systems, like based on traffic density, regulating the green signal. So these are all different type of application. Car parking system, we seen all these in our cases. So this is, so here this is just an introduction to Internet of Things, and Internet of Things as being part of Industry 4.0. You can go more into Internet of, you can as part of Industry 4.0, Internet of Things, self-driving cars, or robotic automation, or augmented reality, virtual reality, all these things comes under in Industry 4.0. These are the things that are going to be leading in the future. So all these will be integrated. So if you take robotic automation itself, it is more liberalized than before. Right now we can use the ROS or ROS2 robotic operating system to make our own, like you can use like off the shelf hardware devices, small hardware prototyping hardware devices, like single board computers like Raspberry Pi or Jetson boards, or controller boards like Arduino boards or ARM boards can be used for making our own automated robots. You can make a manipulator that can precisely, it can move to different degrees, and it can, using object detection camera, using camera you can make an object detection program, and you can place a, either you can use a 3D camera, a stereo camera, or you can use a 2D camera, and you can precisely pinpoint the location of the object, and that location can be fed to the manipulator, the arm manipulator, and the arm manipulator is made using servos. So the servos can give feedbacks, and based on these feedbacks the arm can move to a precise location, to the location of the object, and it can pick the object with a very high precision, with like inches, like a 0.001 inches, like that type of precision it can pick the object. You can make that system on your own. You don't need any you can just go through different tutorials online, and in ROS official website itself they provide different type of tutorials for you can use the like system like move it system for that, or you can make SLAM systems. SLAM means simultaneous localization and mapping system. So using lidar or 2D camera, 3D cameras, you can map the area, and you can make a robot to automatically, the robot can navigate from one area to another area. So this can be used in so many applications. We can make this system as a prototype for a college academic project, or you can use it in case of industrial cases. You can use it in a restaurant. A serving system can be done, a serving robot can be made using that, or in case of a go down, a pick and place robot can be used in case of a robot. A forklift, that doesn't need any humans to work. Right now forklifts needs to be controlled by a humans. So that same forklift can be used in ROS. Using ROS you can totally automate the forklift. So now in ROS you can integrate so many different things, like the lidar you can use for mapping, or 2D camera you can use for same kind of mapping, 3D mapping, 3D camera, 3D mapping, and then you can use GPS for pinpoint location of the robot. So these are all available. These are all open source systems. So it is more liberal these days. and you can make your own small applications using this. So this is just an introduction to in that industry 4.0 case. So you can otherwise you can study augmented reality or virtual reality, like you can study Unity software, how to use Unity software. You can create your own augmented reality applications. You can also refer our own different training programs in Bandagi learning, about augmented reality or robotics or embedded system, whatever it is, Internet of Things. There are like so many different programs are there. You can refer to these